In this video, I will show you how to code your first smart contract on Ethereum. We will use Remix and Solidity. I'm Julian, and on In The Blogs, I help you to become a Web3 expert so that you can get more money, more freedom, and work on projects that you love. So Ethereum is the most popular blockchain out there. This is where you'll find the biggest ecosystem for developers, for users, and for investors. And when you deploy a program on the Ethereum blockchain, this is called a smart contract. It's a small program. Usually it's no more than a few thousand lines of code. And one of the big difference between this smart contract and a traditional application is that once you deploy a smart contract, it's impossible to update it. We say that its code is immutable. It also has a built-in ability to transfer money. So no need to ask for the permission of PayPal to use the API. With a smart contract, it's all built in. There are a couple of programming languages for smart contracts, and the most popular one is called Solidity. Solidity looks simple because its syntax is very similar to JavaScript, but you have to be careful because even though it looks simple, actually under the hood, once you understand it, you realize it's more complex than it looks like. But in this video, we're just going to code our first Ethereum smart contract. And so we're just going to keep it simple. So to get started, we're going to use this tool, which is called Remix. So that's basically an online IDE for Solidity. And to use it, it's very simple. There's nothing to install. You just go to remix.ethereum.org. And you can see that the layout is very similar to VS Code. So we have the menu bar on the left, a contextual menu, and here the main part where you're going to do the coding. So first, we're going to go in the File Explorer and we're going to create a new Solidity file. So we're going to do a simple counter, so that's going to be very simple. And we're going to call this counter.sol. So in Solidity, we usually capitalize the name of our files and the extension is .sol. So we create this file, and so here we're going to code our smart contract. So the first thing to do is to indicate which version of Solidity we are going to use. Pragma Solidity, and then we're going to type the version of Solidity that we're going to use. So at the time of recording this video, the latest version was 08.18, and we terminate our statement with a semicolon like any statement in Solidity. And so if you try to compile this file with another version of Solidity, it's going to give you an error. And this safety mechanism is very useful. So we're also going to activate auto-compile. So here, let's select in the compiler menu, let's select 0.8.18. And here we activate auto-compile. So we're gonna have live feedback. All right, so back to our contract. So the next thing we need to do is to define a new smart contract. And so you do this with the contract keyword. After that, you give it a name. So usually we use the same name as our file. And by convention, we also capitalize it. And so we open our smart contract with curly braces. And inside, we're going to define a variable. So for this, we're going to use the uint keyword. There are different kind of integer in Solidity, but in most cases, you want to use this one. So after you want to indicate the scope of this variable, so here we will make it public, which means that Solidity is going to create a getter function, which will allow us to read the value of this variable. And after we're gonna type the name of the variable, terminated by a semicolon. So this variable that we define will be saved in the blockchain. So if you don't initialize this value, the default value will be 0, but we are going to create some function to change the value of this variable. So we define a function with the function keyword, and after we define the name of the function, then we give it some parentheses, and after we are going to define the scope of this function. So external, it means that this function can be executed from outside the smart contract only. And in general, we try to be as restrictive as possible with the scope of everything in Solidity, because security is very important. And here we open the curly braces to define our function. And inside we are going to use the increment notation to increment count. So here we just use the name of count to reference it. It's very easy. And just with this, we have our increment function. So as you can see, it's very similar to a Solidity function. Here we can increment our variable, but what about for decrement? And for that, we just need to create another function. It's very simple. So here, another function, decrement. And again, the parentheses, we also make it external. And here we reference the count variable again. And this time we're going to use the decrement operator. We terminate this statement. And here we have our smart contract. So here we have a green check mark. So we should have no problem in our smart contract. Now we're going to try that. So for that, we are going to the deploy tab here. And what is really amazing with Remix is that it has a built-in blockchain that you can use for testing and development. It runs only in your browser, so it's a great playground. You can make any mistake that you want. It really doesn't matter. So here it asks you which environment you want. So Remix VM, it basically means that this is the built-in blockchain I just mentioned. And here you have the choice between different forks, but by default, you just want to use the default. That's the latest fork. And so here we are going to deploy and interact with the smart contract by using this account. So on Ethereum, when you want to deploy or modify the data of a smart contract, you need to have an address, and we also call this an account. And so each address is identified by this hexadecimal number. And so this built-in blockchain that I mentioned by default generate a lot of addresses for us to use, and they are pre-funded with 100 Ether. So of course, this Ether is not real Ether. It's just for our development blockchain. So here we're just gonna select the first one. And the reason why we need Ether is because every time we send a transaction to the blockchain, we need to pay for transaction fee, and we pay this with Ether. So we pay with Ether, but it's actually measured in another unit called gas. Since this is a beginner video, I won't dive deeper into the gas concept. But here you can just leave the default. Here value, it's if you want to send Ether to the smart contract, but we don't want to send Ether, so we're going to leave it like this. Here we make sure that we have the correct smart contract selected. Here we're going to click on deploy, and so here you see different things that happen. So first, here in this part of Remix, we will see the details of the transaction that we sent. And here, if you see the green check mark, it means that the transaction went well. And here you can expand this if you want the detail of the transaction. So here we can see the transaction hash. So this identifies the transaction. If we were doing a transaction on a public network, like the real network of Ethereum, which we call mainnet, then we could copy paste this and actually go to Etherscan and see the detail of this transaction there. But since we use a local blockchain just in our browser, it will not work on Etherscan. So after, another thing that changed when we deploy this contract is that here we saw this thing appear in the deploy contract section. So here we expand this, and this represents our deploy smart contract. And here we see that Remix automatically generate different buttons to interact with our smart contract. So it's very, very convenient. So here we can see the address of the smart contract as well here. And here you can see the different colors. So orange is for when you use a function that modify data. And the other color, the sort of gray blue, is when you want to read value from the contract. So let's just read the value of count. We click count, and here, so we see that it is a uint 256. So here we did not say uint 256, we just say uint, but by default, when we say uint, it actually means uint 256. There are different kind of integer and solidity that can hold bigger or smaller number, but by default, you just want to use this one. And the value that was read was 0. So it's normal, it's the default value for an integer. And so now if we click on increment, then we see here that there was another transaction that was successfully sent. And if we click on count again, now we can see that this is 1. So if we increment again, count, then this is 2. And if we click on decrement, then it should remove 1. So now count, and now this is 1. And with this, you've just created your first smart contract on Ethereum. Congratulations. And if you want to dive deeper and you want to get the full process of how to get into Web3 and get your first job in this space, check out my free masterclass down below. It's going to save you a lot of time. All right, that's it for this video. Bye.